For centuries, mathematics was seen as the ultimate human achievement. Pure logic meets brilliant creativity. But what happens when patterns become too complex for even the sharpest minds to see? Enter AI. Not just a calculator, but a creative partner diving into the deepest mysteries of the universe. From solving ancient knots to discovering faster algorithms, AI is uncovering links we've been searching for decades. By blending human-like intuition with machine rigor, we're building a new kind of intelligence. This isn't just about computers. It's about a future where humans and machines propel discovery together. Let's dive into the details for the topic.
AI is changing everything, right? But what happens when it steps into the one field we always thought was purely, uniquely human? Today, we're diving into the brave new world of artificial intelligence and mathematics.
You know, for the longest time, we've thought of math as, well, the peak of human thinking. It's this beautiful mix of pure logic and wild, brilliant creativity. You kind of picture that lone genius with just a pencil and paper, totally reshaping how we see the universe.
So, what happens when something else steps into that world? A new kind of intelligence. And I'm not talking about a fancy calculator. I mean a real creative partner, something that can have its own sparks of genius. To really get how huge this shift is, we first got to appreciate what mathematical research actually is. It's not just crunching numbers, you know? It's this massive quest to figure out the deep-down rules of reality itself. The great mathematician David Hilbert really said it best. He said that math truly comes alive when you find these crazy, unexpected links between different areas that seem totally unrelated. And finding those links, that takes a special kind of mind, a really broad and deep insight.
Okay, so this whole quest, you can kind of break it down into three main jobs. It's this constant loop of discovering something, proving it, and then trying your absolute hardest to break it. So first, you spot a new pattern and make a guess. That's called a conjecture. Then you have to prove it, step by logical step, so that nobody can argue with it. And finally, you switch hats and try to find just one single case where your new rule falls apart. If you can't, well, it's solid. All right, so now there's a new player in the game. A powerful partner has joined this quest, and it is unbelievably good at that first step, spotting patterns. We're talking about patterns so tricky and complex that a person might never, ever see them. Let's look at a really cool example, knot theory. And yeah, it's literally the mathematical study of knots. To tell one kind of knot from another, mathematicians use these super complex labels called invariants. Think of them as a knot's unique fingerprint, describing its shape and structure. And this is where things get really interesting. Human brains have biases, right? We think in certain ways. But a groundbreaking 2021 study showed an AI could look at all those knot fingerprints without any of our baggage. And what did it find? Totally new connections between a knot's shape and its underlying math, links that real mathematicians had been searching for decades. And it's not just in these far-out, abstract fields. This different way of thinking is showing up in really practical stuff too, like making one of the most basic, fundamental things in all of computing, matrix multiplication, way, way more efficient. So DeepMind created this system called Alpha Tensor, and it basically turned this classic math problem into a giant 3D puzzle. It used the same kind of AI that mastered the game Go, and it just played. It played a game to find the fastest way to solve the puzzle. And get this, it found new algorithms that were better than anything humans had come up with in over 50 years. 50! That's just wild. Okay, so that's pattern spotting. What about pillar number 2, proving things? Let's see how this AI partnership is helping to create those rock-solid logical arguments that are the bedrock of mathematics. Check out this number, 25 out of 30. That's the score that DeepMind's Alpha Geometry got on a set of problems from the International Mathematical Olympiad. We're talking about a competition for the absolute smartest high school math kids on the planet. And that score, it's right up there with the gold medal winners. But the big question is, how did it do it? It wasn't just by trying a billion different things. It used this really clever hybrid approach, something called a neurosymbolic system. And this, right here, is a total game changer. It's like combining the two superpowers of AI. You've got the neuro part, the neural network, which is kind of like intuition. It's great at seeing clues and suggesting, hey, maybe try this. Then you have the symbolic part, which is the pure logic engine. It takes those suggestions and checks them with absolute airtight rigor. So here's how it actually works. The neural network looks at a geometry problem and basically has a flash of insight, saying, you know what? We should probably add a new point right here. The symbolic engine then grabs that idea and says, okay, let's see if we can build a formal, logical proof from that. They go back and forth, intuition and logic working together until, bam, they've got a verified proof. So, this team up between humans and machines is obviously incredibly powerful. But it also blows the doors wide open on some really deep questions. Questions about what it even means to discover something, what truth is, what creativity is. I mean, think about it. If the main aha moment in a proof comes from an AI, who's the author? Do you list the AI as a co-author on the research paper? It completely scrambles our whole idea of who gets the credit for a discovery. And that leads to an even bigger challenge: trust. The whole point of math is that other smart people can check your work. But what if the proof depends on the super complex inner workings of an AI that no single person can fully grasp? How can we be 100% sure it's actually correct? And finally, what on earth do we teach the next generation of mathematicians? If an AI can do the heavy lifting of calculation and even proving things, then the human skill set has to change. It becomes less about technique and more about asking the right questions, setting up the problems, and being a sharp critic of what the AI comes up with. We are absolutely at a turning point in history. You've got the oldest, most rigorous science meeting the newest, most disruptive technology. And it's not just a small change. It's forcing us to rethink what it even means to know something, to create something, to discover something new. Look, the point here isn't that AI is replacing human genius. It's about augmenting it, making it even better. We're stepping into a new age where this human AI team could solve problems that were completely impossible before. So the question isn't just, what's the next big discovery anymore? It's who or what is going to find it.